Hello everyone, this is Yadin Rashid. Welcome to my presentation on UML Modeling Basics. I know we have touched upon UML diagrams through Martin Fowler's UML Distilled Chapter 1. However, at times I found myself trying to play catch-up when reading a UML diagram, be it for one of our earlier projects, within text we've covered in class, or even noticing diagrams outside of class. The purpose of this presentation is to break down the design implementations of UML to help you get a better understanding and give you the confidence to apply UML modeling in your future projects. This can be a very helpful tool in software engineering. One thing I want to clarify is that in this presentation, we will focus more on drawing UML diagrams. UML covers an extensive array of information which I probably can't cover within 12 minutes. When I used to see UML diagrams in previous computer science classes, I saw them as a chore and a daunting one. At times, I was overwhelmed and didn't find them to be of much help. If you were like me, the UML diagrams from Dr. K were clear, but perhaps only clear by association. Maybe you feel or felt the same way, or maybe you see the utility in them already. When thinking about UML diagrams, think of them as an outline for an essay. Sure, you can write an essay from the top of your head and wing it, if you will, or you can have a dedicated structure to help keep your thoughts in order, but also even run your outline with a peer to ensure it flows. This almost identically applies in software engineering. Code is articulate art, and while some art is created off a whim, other art is carefully curated. Fowler does state that UML diagrams do not have to be formal, and I couldn't agree more. But just because they can be informal does not warrant the idea that you must have a hard time constructing or understanding one. Here's a fun quote from our beloved Martin Fowler, as well as one from Charles Strauss's The Rhesus Chart. Fowler says, if someone were to come up to you in a dark alley and say, "Psst, want to see a UML diagram?" That diagram would probably be a class diagram. And Strauss tells us, yes, Bob, I rather thought entity relationship diagrams were your sort of thing. You're the expert in Visio, aren't you? Drawing up UML diagrams of fictional vampire brood hierarchies should keep you out of trouble for a while. UML diagrams for a class are broken into three parts typically: the class name, the attributes, and the operations. If your class name does not have attributes, like a field, you can just have two sections, the class name and the operations. The class name itself is quite straightforward. You just write the name of your class. We will go over abstract classes and interfaces in one of the later slides, but for now, just know that the class name goes up on top and is centered. In the fields section, if you have fields, you start off by writing the access modifier. We will focus on public, private, and protected classes. If you have a public field, you write a plus sign. If you have a private field, you precede the field with a minus sign. And if you have a protected field, you write a pound sign or a hashtag. Although we do not work much with protected classes in our class, it is good to know for future implications. After you define the access, you write the attribute name itself, followed up with a colon and the object type. In our example, I created a simple class where we see that our class name is animal and it has three attributes: age, adult, and name. Age is a private and int value, adult is a public and Boolean value, and name is a protected and string value. Under this section are the operations, which we'll go over in the next slide. The bottommost section is the operations section. This is where your constructors and methods will go. Like the attributes section, we start off by defining the operations access, whether it's plus, minus, or pound, for public, private, or protective, respectively. For all operations, we add parentheses, whether there are parameters to add or not, much like our code itself. In our example, we see the full animal class. You will notice that there's no colon after the first operation. That is because the first operation classifies the constructor for the animal class. Within the parentheses, we add all necessary parameters in the order of name, colon, and object type. We separate the parameters with a comma. The remaining two operations are methods, getAge and setAge. GetAge has no parameters, so the parentheses are empty. However, it does return a value, and that is denoted with a colon followed by the object type, in this case, an int. The opposite is for setAge. We have a parameter, but we do not return anything. We still must classify that with the word void after the colon. Here is a snippet of a simple class called person, which I just created. I would like you to pause and think about what the UML diagram for the following class would look like. Take your time to review the code, but do not worry too much of the content of it. Instead, think of how the class would be drawn, and feel free to sketch out your own rendition to compare. Here's how I drew the UML for the person class. As you can see, this example was kept simple. I would argue it is almost too easy of an example to the point where you might have been second guessing, as it were repetitive with the variable names. Our class was split into three groups: the class name, the fields, and the methods. Both the first name and the last name fields were private, hence the minus sign before them. They are both strings, so we denoted that with a colon followed by the type. For the constructor, we added the parameters and their respective types. In this case, they are both strings. Notice how we didn't add a colon, nor return type after the constructor. And for the methods, all our methods were public. So we preceded them with a plus sign beforehand. Our accessor methods, getFirstName and getLastName, both take no arguments, but they do return a string value. We still draw the open and close parentheses to denote that this is a method. The mutator methods, setFirstName and setLastName, do take a parameter each, which are string values, but they do not return anything. Thus we write void after the method. The toString method is structured here like the accessor methods, where it takes no parameters but returns a string value. Now that we know how to draw classes, we might find ourselves asking, what about abstract classes and interfaces? Fear not, as they are quite like the structure we discussed already. The only difference is in the first section, the class name section. For an abstract class, we will italicize the name of the class, and for interfaces, we will use double arrows with the word interface above the class name. The arrows point outwards, thus the less than arrows are to the left of the word interface, and the greater than arrows are to the right of the word interface. As we have experienced in this course so far, a project tends to have more than just a single class. That is why relationships between classes are important to understand as well. A solid winged arrow denotes association. This means the component on the non-pointer side, side A in our case, has access to some of the pointer side, side B, but not the other way around. The inheritance arrow is a full triangle that is not filled. This means that side A extends side B, and every kind of A has an is-A relationship with side B. A is derived from B. The realization or implementation arrow is similar to the inheritance arrow, but instead the line is dashed. This tells us that A implements B, and that B is definition for A's implementation. The dependency arrow is like the association arrow, instead the line is dashed. This means A depends on B, where it may contain B-type objects. The aggregation arrow is drawn with an open diamond, and the composition arrow is a filled diamond. for aggregation, there is a has-a relationship where B has a A. And for composition, take it more like a stronger version of aggregation, where B is entirely composed of A. Now at this point you might say, okay, great, I understand UML diagrams and how to draw them. But then ask yourself, where can I draw them? Surely something like PowerPoint art is not efficient. And you would be correct. UMLs can be written in hand. As we stated, they can be informal earlier in this presentation. Before you resort to that, I want to offer an easy-to-use solution that is adopted by many companies by the likes of Amazon and Google, and that is Lucidchart. I have used Lucidchart for UML modeling for a Java course I took during my undergrad here at Virginia Tech. It was quite resourceful and efficient. Essentially, you're given an infinite grid where you draw out your diagrams. Within the interface, you have an accessible toolset which includes all the shapes and arrows you would need, and perhaps more. The one downside to this is that it does require a subscription. However, I'm not sure if we as graduate students can get access to this through Virginia Tech. This is something I may bring up to Dr. K, as it could be beneficial for other related courses. And that is the end of my presentation on UML Modeling Basics. Thank you for watching, and I hope I was able to provide some useful information. If you have any questions, feel free to comment them under this video. I will be sure to get to them. But until then, have a great rest of your day.